Welcome everyone. Thank you for joining us for today's Fiber Talk webinar series. I'm Rusafi along here with you. We have today with me joined by Matt Zahra. He's the Regional Product Manager APAC for VIAV Solutions. Today our webinar topic is groundbreaking fiber test tools enabling further productivity, automation, and projects analysis. So in this webinar, we will discuss some of the key challenges faced by service providers and their contractors today, and the benefits of some innovations that will enable process flow efficiencies, enhance fieldwork production through automation, and provide analytics to get the insight of how projects are processing. As we have Matt Zahra with us today, so he has been part of VIAV CIVT team since 2016. He is the APAC Regional Product Line Manager, team lead, responsible for business unit activities throughout the Asia Pacific region, and has 20 years of experience in IT and telecommunications technology industry internationally. Just a reminder, if you have any questions of Matt's presentation in any point of time, you can just type them into the question section in the panel. We will try our best to discuss that with Matt at the conclusion, while we will have the Q&A session separately. So now, without much ado, let's move to the presentation. Please welcome Matthew for your presentation.
Thanks, Rusafi, and good morning, good afternoon to everyone that has joined us today. It's good to have you here. Let me share my screen. Okay, Rusafi, is my screen working okay?
Perfectly fine.
Perfect. Okay, so let's get into this. So today, as Rusafi introduced us, we're going to be talking about some of our tools, which, you know, they are quite groundbreaking in the fact that we keep working towards trying to enable teams more with furthering productivity, and we can only do that going forward through automation. And also, on top of that, we will see how the big data that we can extrapolate out of our projects, or the tests done by our teams out in the field, can yield a good project analysis, which can help us become better over the next projects, and so on and so forth. So in today's agenda, first we'll go through some of the trends that we see happening, and especially with things like COVID. I mean, I like to avoid the word, but it's still around us. There's 5G also that is knocking on the door, and everyone is on a race to get there very fast. A lot of network loadings as well, both fixed networks, wireless, broadband. So it's all under pressure at the moment. So then we'll go and see what is this TPA that, if you speak with people from VIAV, we talk a lot about TPA, test process automation. So we'll go through that. We'll have a look at some of the elements that it entails. And then, we can examine a little bit why this all makes sense from a business perspective with ROI. And then hopefully we'll have enough time. We'll run through a quick example, like a live demo, but through screenshots of how you would go about and test the 5G macro cell site, for instance, with fiber construction. So TPA, or test process automation, is quite actually wide. There's a lot of deployment domain areas, and these test areas, they're often required in multiple use cases. So let's say if you're doing a 5G cell site work, you need to do the fiber stuff, there's transport, there's RAN, and then perhaps, next day as a technician, you get assigned to test the fiber to the premise. and you need to test, a bit of fiber, or test the fiber, and the premise with a bit of troubleshooting on perhaps the transport as well. So, long are gone the days where a technician has a very narrow role. We expect a little bit more of our teams today, and the people that make up our teams. So there is no one person, sorry, that can be an expert in all of the areas. And so the way we find to be able to empower people with easy, perhaps automated routines, and to get jobs done without any steps missing, or without a lot of pain, basically, is to have some sort of processes in place. And typically, test results we see are taken, and the data is discarded. So there's a lot of wastage there. And I mean, we can look at ourselves. There is this enormous investment in the labor force and testing networks that operators typically would do up front. And many times all of the efforts would go wasted after the construction part. So instead, we can use, and we can become more valuable, perhaps make use of historical and some of this maybe analytical information that may help answer some of the questions that we see getting raised down the track. So it could be now, it could be in the future. I don't know, some examples would be perhaps something goes wrong and we start asking, oh, was that fiber on the backhaul network built to spec? Perhaps did we comply with all the procedures during the build? Was the REN deployed correctly within the thresholds perhaps that were provided to us? And was there enough margin to operate with perhaps environmental interference with this REN, right? So things like that, from a network transport perspective as well, how will the throughput and speed play with the demand? I mean, do we have the reliability that is needed? So so on and so forth. These sort of questions that perhaps they don't come up during the construct, but later on in the life cycle of network, these questions come up, and maybe there will be items that can be prevented by having the right information. Okay. So through these processes, we see that we can help perhaps novice or people which are not experts execute on these tests, and we can get them through and done through activation, and have some control, audit control through reporting mechanisms. So like I said before, this trend to drive automation is built on the on pressure. Like, we have a lot of connected streaming services now. At the same time, we need to increase the number of people connected. There's network complexities that come along on the backhaul side, for instance, to be able to deliver all that. And then at the same time, we want our teams to be socially distant and perhaps work remotely, and somehow you have to fit training in between as well. And there's maintenance as well that needs to be included, and before you know it, you're really running out of time. So some of the items which can help us reduce some of this workload, which we want to tap into, or which we have been working on tapping into, are having the cloud-based big data captured and processed, and that enables us to automate some of the results, and making use of stuff that is typically in our pockets, like our mobile devices, to enable remote test, API between machines, get information, like GPS, and perhaps use the camera and other things that the mobile smart devices, I should say, actually provide to us, right? So there is this also network densification, which is happening, and it's a never-ending battle, and this is all to enable the speed demand, for supporting this on either broadband, and now we see a lot of pressure on 5G as well. An interesting fact is that, funny enough, all the wireline broadband access supports 90% of the internet traffic, but it ends up terminated on a wireless device. So being over the mobile phone networks or Wi-Fi or what have you, there's an element of both technologies that come into play. Now, from a 5G perspective, 5G is expected also to drive a 5x increase in traffic. But that of course will not be possible without this network densification. Otherwise, it will not remain probably affordable to do so. And we can look at buying more spectrum where it exists, make the same spectrum more efficient, and again densify the network in that manner. And then, of course, you have your enterprise data centers, which also need higher data rates. They use also other tricks like wideband multimode fiber, and perhaps structured cable as well, brings up on that pressure. All right, so here we have a look at what the typical complex modern network looks like. So we have a very varied mix of technologies included, all the way from your core network, which you have the data center on one side, and then you have the head end or central office on the other, and then delivering that through a metro network, typically fiber today, and then you get into the access or into the distribution, where it could be through a DWDM fiber, perhaps, or getting into DSLAMs then on the access side, or HFC also, as we have in several countries in the region as well. We still have coax, and coax is actually growing in places like Australia, and it's also growing in other fashions, like in Japan. We see at the bottom there remote OLT, which is again built on the cable infrastructure, but moving onto fiber, where they're deploying these remote OLTs. So there's a lot of technologies, and then within the MDUs or the homes, we have wireless Wi-Fi as well included in the network, before it gets in the customer, before data gets in the customer hands, basically. Okay, so why do test procedures fail? Typically, when we have a test procedure and it's not followed properly, and this could happen with manual processes, so you can have a lack in the consistencies of MOPs. There's a lot of manual test setups. People tend to perhaps make errors or skip through a few process required processes. So unfortunately, that leads then to poor performance of the process. There's also an element sometimes of cheating, and this, it's not because people are bad, but people are chased by pressure, and it leads to certain activities so that they can keep up with that pressure. So other angles would be workforce challenges. If we have struggle to train up new technicians, or perhaps technicians moving from one technology to another. They can find it hard perhaps to interpret some of the results, and this can lead to some challenges, right? And then, after all that is sorted, you've got the element of manually going through these progress reports. There's a lot of back office, post-processing perhaps, and test results that will need to be assigned to the work orders and location IDs. And if we have inconsistencies in any of these areas, that will probably lead to an inability to audit properly. So all of this can lead to test procedure failures. So then, why should I care about test process automation? So test process automation brings around a loop where it eliminates, perhaps not eliminates completely, but it significantly eliminates from the field any manual work, and also significantly reduces that manual work needed before a job gets in the field. And this is done through automation of data management. It can be done through a system that feeds another system perhaps, and that way, if we have a procedure where we have two systems feeding each other, there's only one manual process, which triggers the first instance, and then the rest is followed through. And this we believe will improve a lot of the productivity, and as we will see through the presentation, and deliver more better quality reporting and consistent with what would be done during the project. So some of the test process challenges that are needed to address these challenges. From a process perspective, I think we've covered a little bit here, but I probably will note on some tests require configurations, and if instruments, for instance, used are not configured properly, you can have inconsistent testing, right? You can have also instruments that perhaps go missing, or that you think they're on one site and then they're on another site. You start getting test reports from different units perhaps that are not corresponding to the right coordinates. From a workforce perspective, again, there can be a little bit of miscommunications that can be addressed, and also from a reporting standpoint, missing or invalid data or lack of quality data can lead to unnecessary repeat work and quality issues. So as a business impact, at the end of the day, this hits the operational costs. So we'll end up with high OPEX. That return on investment time gets longer, and a lot of the times people won't wait for us to improve our processes. They will just move and look for better service from somewhere else. So our offering here is to take control with best practices in this test workflow that we offer. And sorry, let me explain here a little bit. You'll see this cloud-Strata-Sync. So Strata-Sync is our cloud-based database, and which serves as both as an asset management portal and also a data management repository. So here, each step in the process uses the Strata-Sync and the test process automation suite, which organize, if you have a look, it will look into the test inputs needed to track tests. So you can upload your features or your config into the tools, create the job work orders or load them from another system, create those test plans, and then move test results between the technicians coming back from the instrument to the management team, perhaps, or to the quality audit team. And there, people in the back office can look into the results or pass them on to other systems which can crunch some other data from them. There's also the capability to plug in files through APIs, so you can move data from StrataSync to other mechanisms through APIs. But also we have, you can see that mobile phone in the center there. We have an app called Mobile Tech App, so we can also do the app-to-app sharing if that's another type of if that's another type of means to have the mechanics work between two systems. So there's a lot of different ways of how we can flow this data, and typically it will depend on what the operator has installed already and versus what we can provide. Another important point would be to have the instrument always up to date as well. So we have firmware revisions which bring in bug fixes and new features that StrataSync can help you keep up to date. Yeah, basically this would revolve around the whole ecosystem here for TPA. Okay, so here I've put a bit of a workflow chart on how jobs could be pushed along through their cycle. So you can have jobs and work orders created, and then pushed down either manually through a technician, where a technician can, punch on the screen, runs the tests, get the test results outputted, and then you sync them to StrataSync, and off it goes to your analytical engine. And we have means also to authenticate if the results are of good quality. And also what I was talking about before is that you can have an automated way where StrataSync is fed the configs needed, the jobs, the addresses, the technicians that need to attend to those jobs. The system can get all that pushed down into StrataSync, and then StrataSync will assign those different jobs into the different instruments as instrument sync. So then a technician, when they rock up on their first, I don't know, during their coffee morning, they can turn on the instrument, sync it up, and they know what jobs they're going to be closing off today. They can pick a job, go to the site, and initiate their testing, runs the test, closes it off. And like I said, there is an example later on. Hopefully I will get through that as well. So we can, through this mechanism, we can then make a plan to test better. And for that we have a portal also, which is called Job Manager. So here we can create this test plan and push it to the instrument, and from the instrument allows the technician to test it. And the technician closes out through a report and uploads it back to StrataSync. Okay, so a little bit more detail here. I'm not going to go through all this, but there's a lot of things that the technician is guided with, so they can load the job, they can create a report, launch different types of tests, and this is all from the same screen. So they can see the job ID, their location, verify that those are good, and off they go with whatever they need here as the next step. And this is a good way of how you can manage tests needed. So here we're showing an example, for instance, where there's 6 fibers that need to be tested on a particular job, and you can launch these 6 fiber jobs one by one, and then the system, the instrument will let you know which ones have been completed. Perhaps you want to skip one, or maybe it's there's some complication behind it that you want to leave and come back for it at the end. So here you get a bit of a status of where you are and where to go next. And then I mentioned the API workflow, and you know, just to show here a little bit from a compliance perspective, a flow here of how the information is flowing from work orders sent to StrataSync via the API. And we do this with many tier 1 operators. This has been proven a very valuable type of workflow to, you know, to take away a lot of that manual inputting on sites. You know, when you're out in the field, you know, it's not like, you know, being in the office. Of course, for those of you that go out in the field, we all know, you know, you may have dirty hands, you know, it might be raining, so, you know, punching on a screen is not always the easiest. So you want to get through that part and get done with the testing as soon as possible. So if all of that can be done for you, that's where you want to be. And these APIs can help us achieve all that. So I did mention a little bit mobile tech app before. So here we've got an example, and the examples we're using in this presentation come from different instruments that we have. So it could be a fiber instrument, it could be an access instrument or an HFC. So for instance, in this case, we have the mobile tech app, which is connected to an ONX 220, which is one of our cable TV instruments. And here we're showing how we can automatically synchronize the jobs, have a work order ID inputted, and some of the different screenshots here show how we can have the ability then to move the results. We can export them to another app. If it's a config, you can deploy it as well, or you can shoot it off to StrataSync. And also showing here some of the other benefits of mobile tech app. We have already the ability to present documentation. So the tool will identify what it's paired with. If it's an OTDR or if it's a cable instrument, it knows which documents to reference. If you need a user guide or some application notes, you can find them on the documentation section. If you need step-by-step guide, I think I've got a slide coming up that will show that. But also, mobile tech app is used very importantly to extract other pieces of information from your phone, like geolocation. So if you need to append to the report the location or the site or the job that you're at, you can get that through the mobile tech app. One other cool function of mobile tech app is that it gives you the accessibility to get your instrument connected to a smart device. We do that via an app within mobile tech app, which is called Smart Access Anywhere, or SAA as we call it in short. And this allows you to both view and control the instrument. And there's so many different uses that, you know, we actually keep learning of different use cases for this feature from our customers. But some popular ones are where, you know, you can get mentoring for new technicians, perhaps that need some hands-on training, remoting in on some complicated test results, perhaps that they're not really adding up, and perhaps you want to show them to your mate, which is on the other side of town. And also another use case would be to have your instrument connected in a certain location, and perhaps you go up or down the network, you know, moving the cable or doing different conditioning the cable in the network and see if there are any changes happening on the instrument at the same time. So you'd be looking at your smart device, which is connected wirelessly to the instrument, and seeing what's happening on the other side. Okay, so here we're showing on how we can have the ability to perhaps open Job Manager as well on the instrument. And once you verify that the customer name is all good, so this will be all populated when you pick this job. You just need to check that everything is okay. And here you can see the instructions. In this case, we need to inspect a couple of cable connectors, the fiber end and the bulkhead, and run an RFC to 544 test and perform a CPRI check with the same device. Let's say the technician runs into, okay, I've never done, or the last time I've inspected a piece of fiber was a while ago. What do I use from this bag full of tools, right? So here we can even guide the technician on the instrument itself with the user guide, and this would be part of the test process. Okay, so they will have like a help panel here where they can hit it, and it explains everything as a note of what needs to be done, and perhaps which connectors need to be tested. And yeah, Mobile Tech app offers that plus more. So here we can have customer signatures as well as perhaps a sign off on a turn up or a birth certificate. And again, here making use of the smarts within our pockets with these smart devices. So once it comes time for us to collect all of that data from the instrument, we connect it to our smart device. If it's not already, we transfer all those test results into other apps or StrataSync, and that is, the right way we see that needs to be done. If you are a contractor, we also have a setup that allows different types of StrataSync accounts to communicate between them. So we can have an operator StrataSync portal, and you as contractor A will also have another portal. So your technicians under your care will upload into that, and then you can look into the results, make sure everything is fine, and once that's all cleared, you can push them up into the cloud and into the operator StrataSync portal. And as an operator, you can have multiple contractors or subcontractors doing that, and each contractor or subcontractor, they will be independent of each other, so they can only look at their portion, of course, of work and results uploaded through that portal. So once we have all this, here we can see an example of a closeout test reported by a job. So this case example is from a cell site location. It's a customer-facing one. So we have a single report here to verify all the closeouts across, so we can show our customer perhaps, or if an auditor is on site, that hey, I've done all the tests here that I am instructed with. So I had, for instance, 4 inspections here to be done. I had an OTDR check, and then a cable and antenna analysis that needed to be done. So it's been all done, it's all passed, and here's the summary to prove that. You can also take a picture and append that into Mobile Tech app. So perhaps there's a tower or there's a box or what have you that you can add a picture, and that you see at the very bottom here if that was something that was required. So in this way, we start to get a little bit more smart report types, and through that we can start crunching. Management can have a look at KPIs, see how teams are performing by region, by team, see if there's any areas perhaps of technicians that would need perhaps some training, if there's any trends happening, perhaps it comes around that there's a particular area for some reason fibers are failing more. So hopefully all this analysis will help you drill down into what could be what would be causing that. Sorry. And what we came up with also is that we like to see this red, green, pass, fail. We sort of thought we didn't just think about it. Actually, we bounced it off with a lot of operators, and they really liked it and they bought into it. Is they wanted to see a breakdown in percentage with the different types of events. For instance, here of a piece of fiber. So here we're showing continuity, losses, splice losses, connector reflectance, and we're showing the percentages of passes and fails through the tests. And this, of course, will enable us to see how or where we need to improve, and then there could be a better drill down of what needs to improve, so that you get a little bit more green in those red areas. So I think I have 2 more minutes, so I'm gonna bring it all together in this one cool example. So here we start with testing with the test setup and a work order management to the technician with the job manager that we mentioned before, where we fill out all the details needed. You add the test and you can send it to the instrument. You can choose to load a job from a JSON file. Here we've got a template that we can pick on. We load all the job information. We have a list of the test plans here, what tests are needed. And here we're gonna select a technician that we wanna push it down to. We send the job, and then the technician picks it up, syncs on the instrument, gets all the job information, gets the tests that need to be done, and the technician starts working through them. If they want to press on the guide, they can do that. This will come up. Well, this is what I was explaining before. Here we have the screen where he's doing a test done, so we get a lot of passes. Next thing is the OTDR. Okay, remind me how to do an OTDR test. Oh yeah, I need a launch cable. So here it's all explained, and this is our user interface for the OTDR. As you can see, very minimalist. We display the location A to B. We show where the events are, what those events are in more detail, and then some summary of the whole span, right? And this would have been achieved after, of course, the technician presses start. So that would have been passed, and now we're gonna run some cable and antenna analysis tests. That's done, everything's passed, picture would have been taken. And here we're formulating a report. That would have been the report done, and back off to StrataSync. You can do this after every job, or you can do it at the end of the day. It's it's free to flow whenever you get time to do that. And here on the back end, now we can see the job being received on StrataSync on our portal. And we're opening up the summary report. We can see some analytics behind this report. And as you can see, that was all automated. So the only manual processes, of course, was the actual technician having to plug and press the start button, but everything else from a flow perspective was quite automated. So of course, we all need to help with justifying the business case. This is always the case here, where the people that are going to spend money, they need to make sure that they're gonna get it back, and perhaps in threefold or tenfold or what have you. So we need to justify this through the return on investment case. And we're more than happy for those of you who are interested to run some of these sections here on how you can achieve more automated, more efficient, and reduce the errors through an automated test. From our studies, some of the customers we work with, this is what we have reported. There's a lot of gains to be made in the different areas of the network phase, the cycle of the test and the reporting, and not just having the technician portion optimized, but it's the whole efficiency of the workflow that will ultimately add up and give you the full gain. So in our view, test process automation is the best way to manage all this complex complexity in the networks and different technologies, and to help ease the pressure. Do not take the build and pray approach. It hardly ever saved anyone any time. It may in the very short time, but you know, we hear too many stories where it typically will come back to bite. You know, it's something that time and time again, unfortunately, we see. But we're always here, happy to help. And of course, through this, we want you to be able to achieve your metrics and keep the efficiency levels to the highest possible in your organization. And I hope that today, through these slides, I've perhaps managed to show you a little bit of that. I know I had to go through this presentation in a very fast pace, so I hope I will hear or we will hear from some of you. Do not be shy. Pick up your phone and or send us an email, and we'd be happy to organize a time to explain this in further detail. Also, we have a presence online, of course, so welcome to visiting our website. Yeah, that's it for today, Rusafi. I think I just made it on time, right?
Yeah, perfectly fine. So thanks a lot. So yeah, it was really a great presentation. So I think now we can move to the Q&A session if the audience has any kinds of queries or questions. So we will wait for a couple of minutes.
Sure. There's a lot of information to digest there, Rusafi.
Yes,
but
I think
the ultimate message here is that, you know, we are moving into this ecosystem which we call TPA, and we're seeing a lot of, or we're getting reported back that it's working, and more and more people are asking us for it rather than just the instrument itself. It's it is now beyond, you know, just having an instrument on hand. That's not good enough.
Yeah, sure. So so far nothing is here regarding any questions. So just a query. If you have any questions to ask to us, just type that in the question section in the panel, and we will try our best to answer that. So I haven't got anything so far. So I think we can conclude today's webinar. It was really great having you, Matthew. And for the audience, the presentation and the video, recorded video, will be shared pretty much soon, within a week, to our websites and YouTube channels. And also you will receive an email with the presentation and the video file. So if you have any queries, other queries, you can just write to Matthew Zahra and to me as well. So we will try our best to answer that. So with this, we will finish our today's webinar. Our next webinar is next month, and the information will go very soon to you, that on what topic and who is the speaker and other information. So please stay tuned in our social pages and website. So with this, we'd like to say thanks to all of the attendees who attended today, and special thanks to our speaker for today, Matthew Zahra. Thank you for your time. We will be back again. Thanks a lot, everyone, for attending today. Thanks, Matt.
Thank you all for listening. Thank you. Have a good day.
Good day.